Okay, so this video is for my geometry. We have a Chapter 4 summative assessment on Monday or Wednesday, and I have here an extended response question that I think is rather involved. It's a lot about proving triangles congruent, but I think it's a good question, and if you can follow along, this is going to be really good for your understanding of the future for the test. So copy the diagram below. So I would suggest you do that as best you can. It's also in the textbook at the end of the chapter. It says triangle GAB is isosceles with vertex angle A, and angle BCD is isosceles with vertex angle C. Is triangle BGH congruent to triangle BDH? Justify your reasoning. So I'm going to actually go ahead and I'm going to fill in the two triangles that I'm trying to prove congruent. So I'm trying to prove that triangle BGH, that's this triangle, is congruent to triangle BDH, and that's this triangle. So I want these two triangles to be congruent. So I need to either use side, 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 angle, side, angle, side, angle, 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 side, or HL to do that. Now, we are a long ways away from doing that. We have several steps to go. So I might have to scroll up and down a lot to do this. Well, let's start with the given. Okay, what is that going to help us? Well, triangle GAB is isosceles with vertex angle A. Well, what does that mean? Well, if A is the vertex angle, and here's triangle GAB right here at the top. If A is the vertex angle, then that means that it is between the congruent sides. So what that means is, that segment AG is congruent to segment AB. And I'll mark that. It's already marked, so there's AB. It also means, in the other triangle, BCD, if C is the vertex angle, that CB is congruent to CD. CB is congruent to CD. So now, since those two sides are marked, I have congruent angles because of the isosceles triangle theorem. So from this pair, if AG and AB are congruent, then angle AGB is congruent to angle ABG. Angle AGB is congruent to ABG. And from this pair, angle CBD is congruent to angle CDB. And now, because they originally had markings already about being congruent, notice the two triangles. These two triangles are now congruent. Triangle AGB and triangle CDB. Triangle. So I called it AGB is congruent to triangle AGB is congruent to CDB. And that is by I'll use angle, angle, side. And now how does that help me? Well, BG is a corresponding side. So BG here is a corresponding side with BD over here. They're congruent. I'm going to use 3 marks because I already have 2 over here. So side BG is congruent to side BD. And that is by CP CTC. And what is this? This is a pair of sides to prove my red triangle is congruent. And in fact, what I'm going to do is I'm going to label them in red. I'm going to write them in red. And I'll put S next to them. So there you go. So I have a pair of sides. Okay. Now, let's do the easy one. Look at how these two red triangles touch. And I should have done this first. They share BH. So, BH is congruent to BH by reflexive. and that is a second pair of sides. So right now in this picture I have two pairs of sides between these two triangles congruent. So I'm going to cross off I'm going to cross off ASA, I'm going to cross off AAS, and even HL, because there's no talk about right triangles here. So now I need one more pair of things, either the third sides or a pair of angles. Alright, well now here is where we need to look at what's going on down here. First of all, triangle EFG. And I'll use blue, I'm going to use green right here. In triangle EFG, I have three congruent angles. That means that it is an equiangular triangle. And if it's equiangular, it's also equilateral. Equilateral. Well, look at how it's marked, and I'm going to use purple to go along with this. Well, it already has a 2 marking here, so mark the other side's 2 markings. Okay, so how does that help me? Well, now look at these two triangles, triangle EHG and EHD. I'm going to continue in green. So EHG and EHD. Notice now, what do they have that is congruent? Well, they have GE congruent to DE. They have angle GEH congruent to angle DEH. And they share this side. I'll mark it with 5. EH is congruent to itself by reflexive. So look what I have. 2 sides and an angle. And notice what it looks like. Side, angle, side. So these two triangles are congruent. Triangle EHG is congruent to triangle EHD, and that is by side, angle, side. Well, what in the world does that help me with? Well, look at a pair of their corresponding sides. It is 6 markings, GH and DH. They're congruent by CP, CTC. GH is congruent to DH by CP, CTC. And again, I should have done that in red, but this is our last pair of sides that I need. And I'm gonna put a red box around it. So with these two sides here, this side and this side, we have shown that those two triangles are congruent. Triangle BGH and triangle BDH. So, triangle BGH is congruent to triangle BDH. And why is it? It's by side, angle, side. Or, I'm sorry. It's by side, side, side. Sorry about that. Alright. So that was a very, very involved extended response involving all of these congruent triangles. So if you're able to follow that along, all this work, congratulations, you did a very good job. Okay? If not, try it again. Watch it again. So thanks for watching, and we'll see you on Monday or Wednesday.